The simplest form of analysis of variance is called one-way or univariate analysis of variance. So there's basically only one cause of the variation in your experiment. In this particular case here, it's type of cancer. To analyze it in Excel, you need to go to Data. And when you're in Data, then you need to go to Data Analysis and ANOVA. And you can see that there are 3 different flavors of ANOVA that you can actually use. And it's the single factor, which is the univariate ANOVA. So you click on OK. And Excel requires that your data be in columns, with a single cancer like this being in each column. So I'm just going to click and drag over the whole data. I have labels in the first row. It's grouped by columns, and I'm going to shove it into a new worksheet. And OK. And there is my output file. So it will give you a count for each of the different types of cancer, an average. Again, this is useful. So you can see that survival with breast cancer on average is much greater than that for example, stomach cancer. And it will give you a variability associated with each of these cancers. What analysis of variance does is it actually compares the average values in comparison to the grand mean for the whole of the experiment, and compares those to the amount of variability which is associated with each of the different cancers. And the ANOVA table is laid out in a defined format. So whichever statistical package you're actually using for analysis of variance, you'll find the same format. Sums of squares is the sum of the variability multiplied by the degrees of freedom. In the old days, before computers became available, analysis of variance had to be done by pen and paper, or possibly using a hand calculator, maybe even an abacus. So the people working on analysis of variance developed procedures where the hand calculation could actually be simplified or made doable. So this sums of squares was one way of doing it. And you can see that there are 3 sources of variation in the data. There's total, there's between groups, which is due to the fact that the different cancers have different survival times, and then there's within groups, which is error. And then we have degrees of freedom. Degrees of freedom is an abstract concept, but I can explain it simply that, for example, if you had a total for the sum of the 5 different treatments here, and you knew what the mean was, then you could work out, if you had 63 of those values in the mean, you could actually work out what the 64th value was. So only 63 of the items in the data are actually free to vary. So total degrees of freedom is always the total number of individuals in your whole experiment minus 1. In the same way, we had 5 cancers: stomach, bronchus, colon, ovarian and breast. The between groups degrees of freedom is always n minus 1, so it's the number of cancers here, it's 5, minus 1 gives you 4. Error, that is the within groups degrees of freedom, is always going to be the total minus everything else. In this case we've only got univariate ANOVA. There's only one source of variation in your data apart from error, which is your cancers. And there were 5 different cancers, so we've got 4 degrees of freedom. And error is going to be everything that's left. So it's going to be the total degrees of freedom, which is 63, minus 4, gives you 59. This mean square here is the variance which is associated with your particular item. So how much of the variability in your data is due to this between groups, which is your treatments. The fact that different cancers tend to have different survival times. So the variability in your data, which is due to the fact that the different cancers have different survival times, is this value here of 2,885,842. And that's derived by dividing these sums of squares by the degrees of freedom to give you your variance, which is the mean square. In the same way, the error degrees of freedom is achieved by dividing the error sums of squares by the error degrees of freedom. Okay, so we've partitioned the variability in the data to 2 causal sources. One is the fact that the cancers tend to have different survival times, and the other is that within each cancer, not everybody actually lives for exactly 100 days and then dies off. There's variation within each cancer in the survival time, and that's what this error variance relates to. F is the variance ratio, so it's how many times bigger is the variability in your data due to the fact that the different cancers have different survival times, divided by the variability in your data, which is due to the variability within each of the cancer types. Gives you a variance ratio, or F. And the F has a particular distribution, which in exactly the same way that we have a t-distribution or normal distribution, we can cut off a certain proportion of the variability in the data, and a value of 6.43 is actually well into the tail of the distribution. There'd only be a probability of 0.0002 of actually getting a value at least that large. Okay, so this is very, very highly significant.